All right, folks. I guess we'll get started. My name is Adam Feuer. I work for a little company in Seattle called MetaBrite, and we're a data company that have a number of different apps that do data gathering for various industries, like the food industry, things like that. And today I want to talk about building Docker containers with SaltStack. How many people here use Docker? Okay, so quite a few. And how many people use Salt in production right now? Okay, great, a lot of people. And do people here use cloud orchestration systems? Does anybody use like Mesos or Kubernetes or anything like that? A few people, yeah. And how many people here use like their own homegrown systems to run their thing in the cloud, their things in the cloud, like Salt, for instance? Okay, great. Well, this talk is basically about building, the motivation for this talk is on building Docker images for use in a cloud orchestration system. And I don't know, for those of you who haven't used cloud orchestration systems, Docker is the new hotness. It's like, they all seem to consume Docker images like crazy. Every single artifact used if you have a cluster of servers in the cloud, is probably going to be based on Docker images. But the interesting thing about it that we found, so we have several different applications built as clusters. And the problem that we had is that the development workflow is very hard, is hard. Because what we wanted basically was some way for our developers to build these artifacts easily when they're developing, and then test them, ideally in an environment that's as close to production as possible, but without, but while minimizing the complexity of having a cluster running. And then also, we want these images to be built in continuous integration so that they can build branches and test their branches, and when they commit code and merge pull requests, these artifacts get built easily. And people, who's using continuous integration systems, or their team is using continuous integration systems? So a few. Actually a good number of you. And so what we found is that, especially with complicated builds, Docker builds, the things weren't very CI friendly. And so that's how we got started on this. So we had an application called Lectern that we call Lectern, and one of our businesses is scanning receipts and extracting the data from receipt images, basically. So somebody will take a picture with a mobile app that's using our software, and the image will get sent to our back end, where we use kind of a crazy stack of software to get the data out of it. We use Tesseract, which is an OCR software. We use a bunch of machine vision applications, some machine learning applications, and it's all built as a web service. And when we were trying to build this thing, we're heavily built on AWS, and we use this. We're using one of their services called Elastic Beanstalk. They supported Amazon Linux, which is their private version of CentOS, which is a bunch of versions behind the real CentOS. And we just couldn't get our stack of software running on it. But they do support Docker. And so Docker, for us, it solved a real problem. We could run our software on our OS, which was Ubuntu 14.04, and get it out there. So that's kind of the problem. So now we figured out, okay, we can build this Docker image, and our first version, we installed this crazy stack of software, practically a gigabyte of software, and our build. I don't know if you guys have written like build scripts for complicated stuff, but the build was we built it in Bash because it was just the first version, and we just started expanding and expanding, and it just became a twisted, unmanageable thing, And it's running in the context of a Dockerfile. So you go, hey, I have this complicated Dockerfile, and then I also have this complicated series of Bash scripts that I have to run. And just to give you an idea, it's just like nuts. This is like a couple of pages of it, but it was quite long and difficult to run. And then the other problem with it is it took an hour to run, and any failure just set the clock back. So it kind of is a pain in the butt. It worked. I mean, it serves, you know, to date has OCR'd and extracted data from millions of images, but the build was arduous. And so the problem that we wanted to solve, and I was primarily the person maintaining this because a lot of the other developers weren't that into DevOps and weren't that interested in it, and besides it was a mess, so I could see why they wouldn't be. And so the thing I wanted to get out of is maintaining a program that builds my images. And I came to I just want to say I'm a newbie at Salt, so some of the things you may see here, I'm here to learn and find out new things. I just want to share what I've done, but I'm by no means an expert at Salt. But what I wanted to do is get out of the business of doing this. When I came to this conference last year with this problem, I did find the answer to it here. And Ryan Lane's here. There he is. Raise your hand, Ryan. So he gave a talk on how Lyft builds their Docker infrastructure. And the big idea that I got from him, it's not my idea, it's basically use the configuration management to build your Docker images. So you can configure rather than writing code. And of course, he was using SaltStack, and that's my preferred way of going too. So that's what I wanted to do. Here's the goal. Here's our goals basically. We wanted. We didn't want to write any one-off scripts. So we wanted a piece of software that we could use and maybe other people could use. We wanted to be able to build really small Docker images so that we also use microservices, and so, which is also another one of those buzzword compliant terms. But basically we want to be able to reuse different pieces of our Docker builds, Docker images in other services. And we want the development workflow easier, and we want it to be able to run in CI. So I don't want to have to wrestle with CI every time I want to do something like this. Yeah, go ahead. I can take questions as we're going.
One question is, did you consider also using Dockerfiles?
Yeah, so I'll get to that's coming up in the presentation. Why we don't use Dockerfiles, and primarily it's because of this. If you want to do Dockerfiles are great for simple things. But if you want to do anything complicated, and if you've installed open source software, we build our stuff based on a lot of open source software, you know there's always a lot of workarounds. This piece of software kind of works with this one, but then you kind of have to do some configuration to do it, and your Dockerfile either gets to be really long and weird, or you're writing a bash script because you want to test the bash script separately, and you end up with stuff like this. So that's why we started using salt states, basically. The other thing is that we want to run our tests. We want to run tests, and we want to run them inside the container so that they're as close to production as possible. So we know that our artifact is getting tested, and we didn't want to write a bunch of one-off code again to do that. And the other thing we want to basically do is have a system that gives every Docker artifact a very unique name, so that when we're deploying it into our cluster, we know exactly what artifact we're getting. And so this is, so this is what we had before, which is just basically a big monolithic Docker image and a big monolithic script. And what we wanted to get, and what we have now basically, is a bunch of little Docker images that are reusable, which is a good practice anyway. For instance, we have, this is the thing that has salt in it. This is a recent version of Python, our image processing software, and then our app, and then something that runs the tests. So you can see it's kind of more neatly organized. The people here, there were a bunch of people who didn't use Docker, and I'll just briefly say it's a lightweight virtualization system, and it uses, so you can run multiple operating systems on a single Linux kernel. And that makes it really lightweight, easy to use, and the VMs will come up and boot up very quickly. The other thing that it gives you basically is an artifact that you can hand around to people. It can be small or large. Some of our images are quite large because they have a lot of software on them. And Docker has a little bit of terminology they use. Their images are the artifacts. You can think of them as a snapshot of the file system. And then containers, they're the running virtual machine. And you can have multiple running containers on a single host machine, basically. And so this is the question. You said, why SaltStack? It's just I don't want to maintain a mass of bash scripts. I want to be able to just go back to writing code. And basically, every system administration task you can think of pretty much is already battle-tested salt state for it. There's salt modules and salt states for it. And I don't want to write code. I don't want to reinvent the wheel, so that's why we're using that. And then the other thing is we're using salt masterless mode, and I'll explain a little bit more about that. Who here has heard of that before? A few? Okay, yeah. So what we're doing basically is we're not using the central server, and we're running the salt states directly on the Docker containers. So the traditional way to build Docker images is a Docker file, and that's great for simple things. And if you just want to install a bunch of operating system packages or maybe run a simple shell script, that's okay. But if you have something fairly complicated to do, it starts to break down. And then the other way you can build Docker images is really manual. You can run commands. You run a container, and then you can commit to it, basically. You make modifications to it and then commit and take a snapshot of it. The problem with that is that if you do it manually, then you have to do it manually every time you want to build a Docker image, and it's very error prone. And so what we wanted to do, what Ryan's idea basically was use a piece of software to do the run and commit and apply salt states. And so that is what we do. The FlyingCloud is just this piece of software. It's a wrapper around salt. And let's see if I have it. Yeah, this is kind of how it works, basically. And you know, salt there is a little box, but salt is not a little box. It's a gigantic. It's sort of like the TARDIS here. It's a lot bigger on the inside. FlyingCloud is like a wrapper around salt masterless. And so what it does basically is it uses a library called DockerPy. It's a Python interface to the Docker daemon's REST interface. So it gives you a Pythonic interface. But you don't need to know that. But FlyingCloud talks to DockerPy, which talks to the Docker daemon, which can basically boot up a Docker container and then apply salt states to it, like talk through these layers and apply salt states to it, and then commit. And basically push the images to a repo or name them in different ways if you want to, basically, right? So any questions so far about that? Sounds okay? Yeah, Ryan, go ahead.
With your Docker run and commit, when you do a Docker run, just do the full salt run and then the commit of all of the states together at the end?
Yeah, so let me explain that. So basically, you define layers, and I'll go into that here. So you basically say I'm going to make a layer, right? Which is not exactly the same. Terminology is a little bit unfortunate, but it's what we used. But basically, it's like your Docker image that you're going to build, and then you define the salt states for that, and or anything, or you can build it from a Docker file, or you can even write your own Python program if you want. We have a plugin mechanism, and then the FlyingCloud will build that and commit that. And if you have another layer, it'll build and commit that. So it goes kind of piece by piece. So you can choose how many salt states you want to commit into a particular layer. Does that answer the question? Yeah. Okay. Yeah.
So the salt portion or the FlyingCloud portion runs on the host OS that's building the Docker image. Is there any portion of salt running within the container?
Yeah. So what's going on? I'll say a little bit more about this in a couple slides. But basically, you boot the container up. You have to have a base image that does have salt minion installed on it, right? So, because it has to be able to apply salt there. But there's no runtime dependency on salt. And so when you're done, you don't have to have a salt minion listening for anything, basically. So you can turn it off. There's no runtime dependency on it, right? So you're not going to go, when you have Docker containers running in the cloud, you're not going to go and use salt necessarily. You could, but you don't have to use salt to talk to them, basically, and we don't. Go ahead, yeah?
We have a setup that approximates this. We have Dockerfile, calls a script, and the script basically just runs hot state masterless and then has an invalidation line if anything in the repo changes, and then runs the high state again, so that the second time we build a Docker image for the same repo, we're using the previous version that was already provisioned by Salt, because that could take 10 or 15 minutes.
Yeah.
And then we're just doing a delta on that. Does this address the problem of rebuilding with minor changes?
Okay, so I'm not sure. The question is basically how do you, if you have minor changes, how do you?
So subsequent builds of a Docker image with one minor change to the Salt configuration are faster because you're using a cache version that was pre-built using the last Salt stack.
Yeah. So the thing is, this on a dev box, there's two different workflows, right? On a dev box where you're doing this as a sort of a DevOps person or a developer wearing a DevOps hat, and then there's on a CI build server. On the CI server, we use Bamboo and Atlassian Bamboo, but Jenkins does this too, where you have ephemeral build servers, and so the images aren't cached there at all, and so the only thing that we have to work off of is what's in our Docker repos, right? And so when a build box boots up, it pulls down the latest layer. And so when I was showing these layers, basically, so if you have a change to this layer, it's going to pull this layer and base the change on that. Does that make sense?
So you have a shared Docker registry.
We have a shared Docker registry, and the thing is, the CI worker boxes are ephemeral, and so they don't have the. I mean, they might have the layers from Docker, but they probably don't.
How do you keep them ephemeral? Do you just delete the container after you push it to the repository?
Yeah, FlyingCloud will shut the container down for you, and then the CI system like Jenkins or Bamboo blows away the worker box completely, and just it's like an AWS EC2 instance, and it'll just blow it away and disappear. So. Okay, so that's how that works. Yeah, so the layers, they can be Dockerfiles. You can build a layer just based on a Dockerfile, and the first layer probably has to be a Dockerfile to get Salt on there really easily. But then the rest of the layers can be just regular Salt state files, or you can have a Python plugin, and I'll talk a little bit more about that. So this is kind of in the Git repo, which I'll show at the end. This is an example app that's in there. It's kind of close to what we deploy in production. It uses a piece of image processing software from OpenCV, and it's got the different layers, so you can see how to build it, basically. And we'll go through this. And so the first thing you got to configure, basically, is the project configuration file, which is it's called the FlyingCloud.yaml file. It's just a YAML file that says, hey, this is my name. Here are my layers, right? That are available. And then each of the layers, they have a YAML file that describes them. And they'll either have a Docker file or a group of Salt states, and then any other support files they need. And they say which layer they depend on. So FlyingCloud will know, which layer to base it on, basically, if you want to build a later layer. And then if you have like our app, in our situation, these layers don't change very much. We build them nightly, in case there's an operating system upgrade or security updates or things like that. But they don't change very much because they just have support stuff. But then our app changes a lot, and we try to make this as lightweight as possible, so we don't include a lot of stuff in it. And it has the different support software. In this case, it has a Python app running under uWSGI and Nginx to front it for production. And then for to run the tests, this actually doesn't actually build a layer at all. It just pulls the app layer and then executes some tests inside the layer. And it uses a Python program, a Python plugin to do that. There's a way to basically write FlyingCloud plugins that use that. That makes sense. So the project layout is just kind of I'm not showing all the files, but basically it's just a directory with a YAML file, and then a bunch of subdirectories, one for each layer, and then all the support files and states and things like that are in those subdirectories. And here's the file that describes the layer. So I wanted to mention, somebody mentioned, like, how do you get salt onto the container? And so this is the example base layer file, basically, and it's very simple. This is the entire file. So basically, it uses a Fusion base image, which is a battle-hardened version of Ubuntu made for Docker. But you could use anything, Alpine Linux or something like that. But the main line that's important here is, so we install some debugging tools, and salt is installed right there. But this thing in the blue is what's really important. And basically, you normally don't do this on a production server, is you want salt, you don't want salt to fail if one of your states fail, because you want a best effort kind of configuration on a running server. But here, you definitely want to do this. And the reason is because you want your build to fail if you screwed up a salt state. You want your build to fail, and then you can go and fix it in CI or on your dev box. And so this line does that. It's kind of a little crufty thing. I think FlyingCloud would be better if it would do this for you, but we haven't yet figured out exactly how to get it. So it's up to you to put this in the Docker file, the base layer Docker file. And I'm not going to go through these unless people have questions, but this is, for instance, a salt state that defines a layer, and you can see it's getting installing some packages. It configures, here it's configuring some scripts that start up different services in the Docker file. It's just a regular SLS file that you've seen, everybody's seen plenty of those. Here's another example of a salt state file for our app. This is the entire salt state for the app. This was like 3 pages of bash code, by the way. It's interesting. It says use this virtual env, and then install these requirements in there. And the interesting thing is, like, this was where all the bash code came in, because there are a bunch of Python libraries Python modules that cannot be installed by pip install -r requirements. But for whatever reason, the pip state knows how to deal with that, and it can handle that, and it basically individually installs all these things using pip. And so it basically got rid of a bunch of our error handling code here. And then it's basically it's copying our application code in there. How you invoke FlyingCloud is fairly simple. There's a bunch of other options besides these that allow you to push and pull images and set various debugging options. But essentially, you can build a layer, you can run a layer. This is for the dev workflow. If you're on your dev box and you want to go, hey, I want to run this thing, and then connect to it, you can do that. And then you can kill the layer. And that just for the workflow, FlyingCloud manages, like, it knows which containers are running and which layers they're based on. And so it enables you to quickly, you don't have to remember all these weird Docker commands as a developer, and you can just do that. So I'm basically done. I just want to leave you with really one big idea, essentially, is to use configuration management to build your Docker images. You don't have to use Dockerfiles, write bash scripts, and be stuck in a maze of bash. You can just configure, and you can have something that's very easy to use in CI, so that that's friendly to your developers and friendly to your CI system. And you can FlyingCloud will push or pull these to a Docker registry that you can configure. And this is open source. It's not a very big project. It's very small, but it doesn't do a lot. But it solved a use case that we really had, and hopefully it's useful to other people. And we would love the contributors. So if you have ideas or bugs you see that you'd like to fix or have ideas, there's the GitHub repo. There's the docs. It's on PyPy, so you can just pip install it. And there's a mailing list for people who are interested. So yeah, if you have questions, I'll love to have them.
Did you find using your own internal pip repository would be more effective than going out and trying to build all of those things?
Yeah, so yeah, I'll repeat the question. So the question was, what about using your own pip repository? Do you do that rather than fetching them off the net? And so right now there is a really good pip repository that you can just pip install now. It's I can't remember what the name is, but I think we're going to be going to use that pretty soon. We've been doing Python for a few years, and so that wasn't available until recently. And there's this other project called pipexcel. Have you heard of it? It basically allows you to it maintains a local cache of all these. Like a lot of our libraries compile these incredibly intense C extensions, and they don't have wheels for them, because not everybody builds wheels. And so, yeah, it would take us a long time. And so pipexcel allows you to build a cache on an S3 bucket, an AWS S3 bucket, and that's what we do. So our CI instance is what they build, and if they build for a particular version, if they build one, and they look out to the cache and see if it's there, and if it's not, they stick it in the S3 bucket. And say again? Pipexcel. It's called pip-excel. ACCEL, like Excel, like accelerate, pip accelerate.
I had a question about the layers.
Yeah.
From my experience using Dockerfile, and unless I've missed something, I don't know of any way that you can include other layers from other places. So it seems like a place where you get some implicit power here is you've got usable layers. So I guess the question is, with your layers, do they have to be structured like that, or can you refer to layers that are in some other different code?
Yeah, so the question is the layers, like do you have to structure them like this, or can you pull layers?
You've got another slide that refers to the layout of the file system tree for FlyingCloud.
Oh, like this thing, or?
You've got the layers specified in your YAML.
Like this, you mean?
Right, do they have to be in a directory underneath that?
Oh, no. You can basically, they can live, in fact, we do this. So the question is, do you have to specify, do they all the layers have to be in these salt states, and do you have to build them all at once like that? No. You can have layers built and pushed to a Docker repo. We basically use the Docker repo as kind of the authoritative source of truth, right? So your layer basically you can have a layer that says, I'm just referencing this other, like I'm building on, like my layer is a salt state that takes this other Docker image and does something to it.
Right.
And it could be any Docker image, I mean,
Pre-build, not post-build.
say again?
I'm referring to pre-build. So the whole entire Docker, the salt state,
Yeah.
it's referenced in that as a layer. I want to know if I can refer to that in some of the other repo where it's just a self-contained salt state, and that's it.
You can refer, I'm not sure I'm getting.
If I've got common images that use the same layer over and over, then I've got to replicate that layer in this tree and keep doing the same thing.
Yeah, you don't have to lay it out like you don't have to lay it out like this.
Right. So
like,
can I reference some other Git repo and say that that's over here and not in this file tree?
Oh, you mean to share this SLS files?
To share the layer and specify the salt.
I don't exactly know how. We're all in one. We have our things all in one big Git repo, so we don't do that. The way we basically say is build a Docker layer and use that. But you could use Git submodules to do the same thing, basically, if you put the states in a submodule. And talk to me afterwards, and we'll figure out like how to do that.
You could sit in the same place. It could be reusable from the.
No, I totally get what you mean. You might want to use the same state somewhere else, right?
Specific to that image that you're going to be reusing it, that needs to live in there, right?
Right. And so I don't exactly know how to solve that, but talk to me afterwards. We'll figure that out because that's a really great idea. And then you.
About image naming, you said earlier that each image needs to be named uniquely or something like that in one of the requirement slides.
Yeah, well, the thing is, okay, so the question is, I said something about naming the image uniquely, and say more about it is basically what you want to know. So the thing is, what we discovered, I mean, it's fairly well known. You want to, when you deploy a cluster of servers or something like that, you want to know exactly what's deployed in production, what artifacts are running out there. And so you want to be, we thought we want every Docker image. Like I don't want to just deploy lectern : latest, right? Because that could be anything, what I want is something with a name, a name. And we decided to use a timestamp name, basically. That's, lectern dash, 2016 05 72, whatever. And that's unique. It's basically guaranteed unique by the CI system, essentially. So that when you look at a cluster, you go, hey, I know that Docker image is running out there, and I can, if I need to fix it, I can deploy a different Docker image instead of just going, hey, it's just latest, and I don't know what. Does that answer your question?
Yeah, but why not use the build number from Android?
And it basically does include the build number. So it has but you can override the FlyingCloud code. It basically goes name dash build number dash timestamp. So you have both. You had a question in the back. That'll come to you.
Do you mind going back to that architecture slide that you had?
This one?
Yeah.
Yeah, this one.
So if you want to do Docker and SaltStack without FlyingCloud, how much more difficult or easy would it be?
So you want to do all this plus this without FlyingCloud?
Yeah.
Well, that's what we started out doing, and then we were like, well, we're going to write a bunch of one-off scripts, basically, that need to manage your communication between the Docker daemon and FlyingCloud, basically, right? And so there's not you can look at the code. It's not that much code, but I mean, you can definitely do this yourself, but we wanted to provide some infrastructure for people who maybe wanted to get a head start. Does that make sense? I mean, definitely look at the code and see how it works. And if you have a better way to do it, it's Apache license, so just take what you want.
Before you were looking at a few hundred lines of bash code, and now you're looking at a few dozen lines of YAML.
Yeah. So
Can you give me rough numbers for that?
Yeah. So before we basically had. I mean, it was kind of scary. It was probably like 2,000 lines of bash, and now what you're looking at, it's a little bit more complicated than this, but you're looking at basically a handful of config files, and where all that goes basically is because Salt wrote it all. Right? Salt, that's what Salt is. It does all this stuff. And I don't have to do, I'll have all this weird error handling in bash, and I don't have to do rsync and copy my files in there. And it's just like, that's what you get from standing on the shoulders of someone else who's awesome, And that's what's going on, right? Any other questions? Great. Well, it's time for lunch, so, sorry, one more, yeah.
Are there any other tools besides FlyingCloud that
If I knew about them, I would have used it instead of writing this. I tell you, like, it's kind of a weird thing. Like, I don't know. It seems obvious because there are a lot of other configuration management systems too, like, like Chef and Ansible and Puppet and things like that. It just seems like an obvious idea that if you that there should be, but I haven't seen any. And so if you know of any, I'd love to know them because
Packer kind of does?
Yeah, Packer kind of does, but it doesn't. My understanding is it doesn't. Like there is this thing in Vagrant where you can apply Ansible states, but I couldn't build a Docker image off of it. You know what I mean? That's the thing. So there was another question. Sorry. No. Okay. Great. Well, I'll be around afterwards. I guess they want me to say give feedback, so please provide feedback to SaltConf using the app if you want. And I just invite you to go to GitHub, download this, see if you like it, see how it works, and let me know if you have questions.